Hello everyone, in this video we cover the language A raised to n, B raised to m, C raised to m, D raised to m, and second and third. These three language we cover here. So we start. So first start with first language. L is equal to A raised to n, B raised to n, C raised to m, D raised to m. So here for the B raised to n we pop A raised to n, and for this D raised to m we pop C raised to m. So for that what we do, first push the A raised to n, push, then when B read that time pop the A's, then we reach to the Z naught here, and when we read the Z naught that time push the C's, and after that when you read the D that time pop the C's. So let's suppose here m is equal to 2 and n is equal to 3. This is the too much longer string is formed, so we take n is equal to 1. Let's suppose if you take the 3 then it is also okay, but it take more time to perform here in the stack. So n is equal to 1 means A raised to 1. So A, B raised to 1 means B, then C raised to m, and m is equal to 2. So C raised to 2 means 2 times C and 2 times D. So this is the string we consider for the example. So here we consider the stack. So this is the stack. Initially Z naught is present, then we read A, then push the A. When if n number of A is present, then n number of A's you push, and if only one A is present then also it's okay, but we take n number of A's and B's. So let's suppose 3. So 1, 2, 3 A's and 1, 2, 3 B's. Now it is understand easily. So we see initially read A, we push the A's, again read A, push A, again you read A, push A. Now you read B. For the first B, pop the first A, again you read B, pop A, and for the third number of B, third number of A is pop. Now the stack is empty, but now you read C. So when you read C and initially Z naught is present, then push the C. So we write here C, we push the C, again you read C, push the C. Now you read D, so you read D. So for the first D, pop this first C, again you read C, D, pop the second C. So in this way all the stack is empty, and you read Z naught means here is the null is present. So null and Z naught means we are in the final state. So in this way we think about that question. So we now draw the PDA. So initially Q naught state, first we read all the A's only, because string is always start from the A's. So Z naught is present, we read A, then A Z naught, then second time already A is present, you read A, then A, push the A's. Now we read the B, so for that write the transaction and we perform the pop operation. So initially A is present, we read B, then pop the A's. Now we are second state, and here also cycle is formed. If n number of A is already present and we read B, that time null the A's. Now we read C. So again we perform the push operation. So change the state, and here already now what present in the stack, only Z naught is present. Here all the A's and B we pop, so null is present. So right here initially Z naught now present in the stack, and then we read C, then push the C. So we read C, then C Z naught because we push the C. And now we are second state Q2 state, and here also if n number of C is now come, and we read C already, then C. Okay, now we change the state because now all this C we push here in this cycle. Now we read D. So for that we now perform the pop operation. So right here next state. So already C is present and we read D, then pop. So we pop the symbol and we reach to the next state, Q3 state. So here also we perform the same cycle. If n number of C is already present and n number of D we read, then pop the symbol. And now we are in final state, means here null we read. Initially Z0 is present, then Z0, and final state Q4. So this is the final state. So this is the PDA for this language A raised to n, B raised to n, C raised to m, D raised to m. Now this is the second language, A raised to n, B raised to m, C raised to m, D raised to n. Now which logic we apply here? So first we push all the A's and then we read B, then we push this B also, because number of B's and number of C's are the equal. So only here possibility is n number of C, for that m number of B we pop, and then only A is present in this stack, and when we read the D, that time n number of D we pop n number of A. So let's suppose we consider the example. A is equal to 2 and A not n is equal to 2 and m is equal to 3. So the example string is A because A raised to 2 now, B raised to 3 because m is equal to 3, so B. Now C raised to m means C raised to 3, so 1 2 3, D raised to 2, so D. This is the string. Now we draw here stack. So in this stack initially Z0 is present. Now we read A, so push the A. So basically I hope now you build your logic is that if n number of one symbol and n number of second symbol is present, that time you pop the symbols for each other. Here now we see in the example and build your logic clearly. So A is present, we push the A. Again A we read, push the A. Now we read B. So for this B we pop the A? No, because number of A's and number of B's are not equal. Number of B's and number of C's are equal. So it is easy to pop the B's for these C's. So we push the B's. So first A is present and we read B, push the B. Again we read B, push B. Again we read B, push the B. Now we read C. So for this first C we pop the first B. Again we read B, C, pop the B. Again you read C, pop the B. Now all the C's and B's are now completed. Now here A is present and we read D. Now we are in this state. So we read D and A is present, so pop the A for the D. Now again we read D and A is present here initially, pop the A. And now here empty stack is present, means we are in the final state. So in this way build your logic, means if n number of symbol is present and another symbol is also n, that time pop this operation is performed for each other. So now we draw the PDA. So at the initial state Q0, initially Z0 is present and we read A, then A Z0. Again A is present and we read A, that time AA, push the A's. Now again B is read, and we also want to push the B's. So we perform this transaction in the same state because we want to push, not pop. So same here we do. Initially A is present, we read B, then BA. Write this sequentially here. Now B is present, and our reading with this symbol is also B. Then that time also push the B, so BB. So here all the push operation we perform. We push A also, we push B also. Now we pop. When you read the C, that time pop the B. So initially B is present. Here we see B is present and we read C. That time pop the B's. So B is present. We read this C, and that time we pop the C's. And we reach to the second state, Q1 state. Now in Q1 state, all the B's are pop for the C. So already B is present, we read C and pop the B's. Now next, in this way we complete all the B's. Now we read A, and that we read D, and initially A is present now. So that's why we take another state where first A is present, we read D and pop the symbol. So now Q2 state. Here also the same cycle is repeat. Initially A is present, we read D and pop the symbol. And in this way we complete all the symbols. And now we read null is present, we read null. Initial Z0 is present. When all these A are the pop, that time only Z0 are the present in the stack. So initial Z0 is present. Now we read null and Z0. So here we are in now final state Q3. So this is the PDA for A raised to n, B raised to m, and C raised to m, D raised to n. I hope all you get idea about this. Now next language is A raised to n, B raised to n, and C raised to m. Now which logic you apply? So as I say, what you perform here? First for the A raised to n, we pop for the B raised to n, means equal number of A's are pop for the equal number of B's. Am I right? Now C is remaining, C raised to m. So for that same logic we apply, which we apply for the here A raised to n and B raised to m. So here what happening? We pop all the A raised to n for the B raised to n, and remaining which B are the remaining now. So for that we perform nothing. We kept B as it is, means we convert this to the null, or the Z0 we kept as it is. So same logic we apply here. So for our simplicity we consider the example. So let's suppose n is equal to 2 and m is equal to 3. So string is from AA, BB, because n is equal to 2. So A raised to 2, B raised to 2, and C raised to 3. So 1, 2, 3. So this is the string we consider. Now this is the stack. So initially Z0 is present. Now we read A, push the A. Again read A, push the A. Then we read B. So pop the A for the first A. Now again we read B, pop the B. Now here Z0 we now read. So what we do? But here is the C we read. So kept this C as it is for Z0. So if we read the C, we perform nothing. We kept this Z0 as it is. Again we read C, kept Z0 as it is. Again we read C, kept Z0 as it is. Now the string is completed, means we are in the final state. And here is also this upper side, all the null values are the present. We read Z0, and means here we are in this final state. So for that, which transaction we write here? So already C is already which symbol is present? Here I write Z0 is initially present. We read C, so we perform nothing. We kept this Z0 as it is. Not we push anything, not we pop anything. We kept this Z0 as it is. This is the operation for C. Now we write the PDA, draw here, so we can understand easily. So here first initial state. So in this initial state what we do, initially Z0 is present. We read A first, string is start from A. So A we read, so we push the A Z0. Now next again A is already now present, here we push, so that's why. And we read again A, so what we perform? Push operation A. Now we read B, so for that pop operation we consider the next state, Q1 state. So here in this state what we do, initially A is present, we read B, pop the symbol. Same cycle is formed here for this Q1 state. Again initially A is present, we read B, pop the symbol. Now we in this way we complete the A's and B's. Now C is come in the picture. So here now initially Z0 is present because all the A's are the completed for the B. Now initially A Z0 is present, we read C, so kept Z0 as it is, not perform anything. And the next state, Q2 state. Here is also now n number of C's is come in the picture. So that's why the transaction is initially Z0 is present, we read C, kept Z0 as it is. This is now not the part of this is the transaction. So C Z0 kept as it is, and the final state is null. Now everything is completed here, only Z0 is present, so null Z0, and we are in the final state, Q3 state, which is the final state. So this is the PDA for the example A raised to n, B raised to m, and C raised to m. And now if the question are for only 3 to 4 marks, then only PDA you draw. And if the question is for 6 marks, 7 marks, then that time the transaction table is also required. Now how we draw this table? Now we see. So first table draw for the Mo number. This is nothing but the serial number, means 1, 2, 3, 4, this. Now next for the state, then inputs, then next symbol is for stack symbol, or we say that this is the initial symbol which is present in the stack symbol. And now last is move. Now how fill this table? Now we see, it is too easy. So first see the PDA. Now first which state we consider? Initial state Q0 we consider. For that how many transaction we write? 2 transaction we write. So first Q0 write 2 times because 2 transaction are the present for the Q0. Now write this bracket as it is, A Z0. So input is A, then initial state symbol is Z0, and move is A Z0. As it is we write the bracket here, but in the table form. Now next A. So initially A, second one is A. Now next this state is Q1 state. So only one transaction is present for the Q1. So write one time Q1. Now symbol is BA null. So write as it is, BA null. But before that, this Q1 one transaction, this BA null is present, but this is same we write as it is here for the Q1, but this transaction is performed first by Q0, not Q1. So this is the Q0 state, not Q1. This transaction is performed by Q0 state, so Q0, and this bracket write as it is, BA null. And now for the Q1, not write this bracket again, BA null, because this is already we write for the Q0 state. So this second transaction write, which is performed by this Q1, which C Z0 Z0. So right here Q1 and transaction is C Z0 and Z0. Now the Q2 state, not write this bracket again because already it is performed by the Q1. So next transaction Q2 null Z0 Z0. So fifth number transaction is Q2 null Z0 and Z0. So this is the table is formed. So if the question for the 2 to 3 marks or 4 marks, then only PDA if you draw, then it is enough for that question. But the question is for the 6 marks or 7, 8 marks, that time PDA, this PDA plus this table is required, and then we get out of out marks. So now we stop here. If any doubt or any query, then let me know in the comment box. Thank you.